Good afternoon, everyone. My name is Yan Jiang. The author of this paper, Dr. Fengchen Yang, can't be with us today due to some unexpected situation. So I will present this paper on behalf of him. This work is a new type of EMI attack, which is LightAntenna, characterizing the limits of fluorescent lamp-induced electromagnetic interference. Fluorescent lamps are widely used in our life, such as medical, household, and industry, or the meeting rooms. According to the many market reports, the global size of this lamp has increased greatly over the past years. So we can see that this lamp plays an indispensable role in the IoT world. However, in recent years, fluorescent lamps have been reported to interfere with many IoT devices. For instance, it will affect the touch screen of iPhones and the Surface laptops, or impacting the signal of radio, TV, and internet. However, the underlying principle of the lamp-induced EMI has not been clarified. Based on this idea, our goal is to understand the underlying principle of the fluorescent lamp-induced EMI and quantify the EMI impact on IoT devices, and investigate the impact of fluorescent lamp-induced EMI on sensors. We name our work LightAntenna, and this is our attack scenario. An attacker can inject malicious signals into the public power line. To launch the EMI attack nearby the IoT devices, such as the sensor manipulation, voice injection, and other EMI threat extension. To achieve LightAntenna, we need to answer two questions. The first question is, why can the fluorescent lamp can be used as an antenna? This is because both of the power source, the metal cable, and the circuits will also can be produce the EMI. The second question is, how's the fluorescent lamp's antenna performance? Since previous EMI works require specific metal antenna, but this lamp is not designed for EMI, so it may not perform well as a metal antenna. To answer the first question, we need to understand how this fluorescent lamp works. The lamp contains a real gas. When electricity passes through the gas, it will excite the phosphor coating inside, which then produces visible light. However, the ionized gas will form a plasma with conductivity, so the fluorescent lamp's tuber can be considered as an antenna at this point. To answer the first question, we measured the EMI of the incandescent lamp, the LED, the ballast of the fluorescent lamp, and the tube of the fluorescent lamp. We find that this lamp cannot be replaced by other lamps, and the EMI mainly comes from the tube of the fluorescent lamp rather than the power source of a ballast. To answer the second question, we measured this lamp-induced EMI intensity and frequency response. The result shows that the lamp-induced EMI has an ideal frequency in the band range of EMI attack. Then let's design the LightAntenna. And there are two main steps. The first step is to control the fluorescent lamp to generate EMI. Considering that the target fluorescent lamp may be powered by the AC grid or the DC battery, we designed the RF AC coupler and the RF DC coupler respectively. However, our one problem is that whether the ballast circuit allows the transmission of the attack signal. To investigate, we conducted a frequency sweep test on the AC and the DC ballast. And our result shows that both the AC and DC allow the transmission of the high-frequency signals. The second step is to control the fluorescent lamp to generate controller EMI and manipulate IoT devices. In this work, we focus on two types of attack scenarios. The first attack scenario is to inject signal frequency signals into the simple analog sensors. And the second attack scenario is to inject more complicated voice commands into the microphone. We selected the AM method to modulate the EMI signal. For the single frequency signal, we set the wanted wave as the baseband signal. And for the voice injection, we set the voice signal as the baseband signal. For the sensor manipulation, we selected 8 different digital and analog sensor modules, and we adopt an EMI shielding box to avoid external interferences. After injecting EMI of different frequencies into the fluorescent lamp, we successfully achieved EMI attacks on all sensors. Especially for the industrial temperature sensor, we achieved an arbitrary manipulation of this temperature value. For the voice injection attack, we selected the gooseneck microphone that is used in the meeting room like this. And in order to verify whether fluorescent lamp can inject signals in voice band, we first injected a modulated 0 to 2 kHz chirp signal. According to the frequency response, we can find that the lamp-induced EMI can cover the speech band. Since ghost talk is a typical example of using the EMI to inject a voice signal into the microphone, we compared the effect of LightAntenna and the ghost talk injecting OK Google, and we achieved similar effects. Then we inject 50 sentences into the microphone and recognize them use the three typical speech recognition models. We achieved a recognition rate of over 70% for sentences and 91% for words. To evaluate the antenna performance of fluorescent lamp, we compared the signal intensity and attack distance of a fluorescent lamp and 8 different metal antennas. The experiment results shows that the EMI performance of the fluorescent lamp are weaker than the directional antennas, but is similar to the near-field magnetic probe. Besides, injecting attack signals into the power in a real grid may face a challenge from the grid components, such as the switch, leak protector, and so on. To investigate, we built a 3-phase distribution cabinet and evaluated the impact of grid branches on LightAntenna. First, we found the attack signal should be injected into the phase that is connected to the target lamp. And second, the main switch, L switches, and the leakage protector in the grid have little impact on the LightAntenna. Finally, the isolation transformer will block the attack signal. Then, other devices connected to the same grid branch as the target fluorescent lamp may also affect LightAntenna. To investigate, we qualified the effect of the working desktop, charger, speaker, and multiple lamps. We found the working desktops, chargers, and speakers have very little effect on the LightAntenna. And when another fluorescent lamp is connected next to the target lamp, the EMI signal will be enhanced. To illustrate the LightAntenna can be developed as a practical attack method, we designed a portable and cost-saving attack device and achieved EMI attack on sensors. We systematically analyze the underlying principle of how fluorescent lamps generate EMI and how to control them. Second, we design and evaluate the light antenna tech on 8 different sensor modules and a microphone, and evaluate potential impact factors. And last, we discuss the potential countermeasures of light antenna and design a portable tech device. That's all my talk. Thanks for listening. Maybe I also can answer some simple questions. Yeah.
Okay, is there any question? Yeah.
Thank you for the talk. I think that's the third now I hear from you.
Yes.
Quite impressive. Do you know about the radiated power output of the lamp?
Radiated power?
Yeah, like in dBm, say. Do you know like how much power is being produced by such a lamp?
Sorry, the technical details maybe
Okay.
I'm not very familiar. Yeah.
Thanks anyway. I will consult the paper.
Okay.
Thank you for the talk. And I have one question. So, did you evaluate your work against some several countermeasures like human speech recognition, like distinguishing between the machine-generated like speech or human-generated speech?
Yeah, we evaluated 3 speech recognition models, and it demonstrated our text feasibility.
Thank you.
So yeah, we still have time. Yeah, that's why. Let me ask
Okay.
one simple question. Yeah.
Okay.
Yeah, I will not bother you. Yeah. So can you little bit discuss about how can we mitigate or prevent these attacks?
Prevent this attack?
Yeah.
I think a very simple solution is
Using LED lamp? Do you mean the using LED lamp?
it's a good choice, but you can remove your microphone far from the fluorescent lamps, and or you can put some shieldings such as metal shields, but can penetrate the light on the fluorescent lamps. Yeah.
Yeah, I think we can discuss further in offline. Yeah. Okay.
Okay.
Yeah, let's thanks
Okay,
to the
thank
speaker
you.
again. Yeah.